Namaste, Mr. Bossart here. We talked a little bit about polynomials prior. And so today's is going to be mostly review, just getting you back into the swing of things. Our last kind of couple sections of the year, we're going to talk about some things with polynomials. So polynomials we know is much or many terms. It's an expression that has any term or terms, right? So a term can be a number, a variable, or a product of numbers and variables. So we've got 5x as a term, 8 would be a term, negative 22y. Those would all be one-term polynomials. So that name for them is monomials. Monomial is a one-term polynomial. Here we have three expressions, three polynomial expressions. The 33xy is a product of 33 and x and y, and it is one term, and that's a monomial. Below here, right, we've got two terms, 22x and negative 85, so we would call this a binomial as two terms. And below we have a three-term expression, right? It's three terms because x squared, x, and no variable. You can make a claim that this is an x to the first term, x to the second term, and this is really an x to the zero term, which we would not even we wouldn't write or entertain that part of it. So that's why it's just a constant, right? But they have different exponents. So this three-term expression obviously would be a trinomial. If it has more than three, we just call it a polynomial. So four-term polynomial, five-term polynomial. A vocabulary word for this, we could have the degree of a polynomial. The degree is the number of exponents in any one term of the expression. Okay, so if we look at this expression, 16x squared y to the third, that's one term. There's no pluses or minuses in there, and it has degree of 5 because it has the number of exponents on the variables is 5. So this term would have degree 5. 3x squared. 3x squared has degree 2. That term has degree 2. All right, now thinking about, right, if I have 435 plus 7,412, why don't I add the 4 and the 7 together for 11? Or the 3 and the 5, 3 and the 5 to make, how would 3 and 5 make 9, Bossart? That's the worst thing I've ever written, right? It should be, obviously, the 4 and the 5, right? This Anyway, we know the answer to that. The answer is that they need to be like terms. So if you add or subtract, you got to combine like items or like terms or places or values or denominators, etc. But they have to be like in order to add or subtract them. All right. So when we add or subtract polynomials, they have to be like terms. And we understand this part, right? So if I have negative 10z squared minus 25z plus 15z minus 2, the parts that I can actually add together here, right, are the z to the first terms. So I'm looking at negative 25z and positive 15z, which would be a negative 10z. And then the other two terms, the negative 10z squared and the minus 2, we'll just go along for the ride. And so my answer would be a trinomial. We know that up here in the red, I can subtract these, right? I subtract, and really, right, if I go back, this is really a 6th grade question. What's 3 minus 10? Negative 7. Negative 7 what? X squared. So this is negative 7x squared. And we understand that in green down here, we cannot subtract those because they are unlike terms. I'd have to leave it as a binomial, whereas I can combine these two like terms to make it a monomial. Okay. Well, okay, great. What find each sum? I mean, come on, right? This is so easy, Mr. Bossert, right? And it's the same if I say right now, this problem up here, number 1, no problem. Battle, positive win by 4. Even though it maybe looks a little bit more complicated, right? I'm hoping by now you understand, right, that these are the same dealios, right? They are both x to the 3rd, y to the 4th, z to the 8th terms. And so number 1, this question and the question below, they are exactly the same. It's just 4 of these highlighted things. In this case, it's x to the 3rd, y to the 4th, z to the 8th. Right? If we combine these, again, combining, adding, or subtracting, but adding these two trinomials, we add the like terms. Of the yellow x squareds, we've got 3 plus 4 is 7. The x terms, we have negative 10 and negative 3, which is negative 13. And the constants, I got positive 7 and negative 10, which is a negative 3. All right, take a minute to copy this and do a right answer, and I will come right back. Okay, there we go. Combine like terms, we should have 8x squared plus 2x minus 5. All right, give this one a try. I'll be right back with the answer. Okay, so again, since I'm adding, I basically just need to look at the coefficients and add those and tag along what kind of term it is for this answer. All right, we know that if I'm subtracting, I don't subtract. I add the opposite of negative 12, which is 12. Call that 20, right? Welcome to the beginning of the year. So now if I'm subtracting, right? I'm subtracting 3 terms here. So I need to subtract each one of these 3 terms. Subtract negative 3x squared means plus 3x squared. Subtract negative 2x means plus 2x. And subtract positive 8 means minus 8. So again, I would always say that we should rewrite subtracting as adding the opposite. And now go ahead and, combine your like terms. Combine the x squared to get 7x squared. Combine the x's to get negative 2x. And then combine the constants to get negative 6. And then, so if we wrote the answer here, we'd have 7x squared minus 2x minus 6. Subtracting is adding the opposite. Subtracting 3 terms is adding the opposite of all 3 terms. All right. All right, try this problem and come back when you and pause it, and then come back when you have the answer. Yep, there you go. Changing all 3 of these, almost like you're distributing this negative, subtracting to all 3 of those signs. So change all 3 signs to the opposite, and then combine your like terms. All right, take 1 minute, jot down the answer to those 4 problems, and we'll come back. Okay. Again, careful about the m's here at the end. 5m and it says m, so that's 1. 5 plus 1 is 6. Okay. Give these a shot. Pause it right now, and then give me the 2 answers. Okay. Did you go 2 for 2? Good for you if you did. All right. Last one of these. Pause it. Be careful. Watch the like terms. And come back with your answer. All right. a lot of singles. The only like terms we have are the x to the fifths and the constants. And then notice for the x to the fourth term, it's minus a negative 3, which means plus 3x to the fourth, plus 3x to the third, and then minus a positive 2x becomes minus 2x here. All right, back to remembering our rules when we are multiplying like bases. This would be 6 to the 13th. A to the 4th times a to the 11th is a to the 15th. If I'm dividing like bases, I can subtract the exponents and keep the base the same. So this becomes 7 to the 9 minus 7, or 2, 7 to the second. And then here I would maybe multiply these to get 24z to the 13th over 6z to the 6th. Then 24 and 6 would divide to be 4. Z to the 13th, z to the 6th, subtract the exponents, it would be z to the 7th. So maybe write this part down, but when multiplying and dividing with polynomials, we multiply coefficients, we multiply the variable terms, which means we add the exponents. Be careful of those exponent deals. So when we're multiplying, we can add those exponents. When I'm dividing now, I can either treat it as reducing a fraction, or dividing the coefficients and dividing the variable terms, which would mean to subtract those exponents. So number one, if I'm asked to multiply these two monomials together, I will multiply the coefficients first. So 3 times negative 6 is negative 18. And then I'm going to multiply the variable terms by adding the exponents. So the x's, x to the third times x to the fourth is x to the seventh. Y to the second times y to the negative 6 would be y to the negative fourth. And you may remember that we did then say sometimes we'll write it so that you can't have any negative exponents, in which case that y to the negative fourth drops to the denominator and becomes y to the positive fourth in the denominator. So depending again on the direction, if it just says multiply, this first answer would be great. If it says leave your answer with only positive exponents, you need the second answer. Again, multiplying these, negative 2/3 times negative 9/4. Oh no, they're fractions. Well, too bad. All right, but certainly we can handle that. Becomes 18 over 12, which is 3/2. X to the 8th times x to the, it doesn't, not written there, but it's a 1, so it's x to the 9th, and y to the 3rd. So that would be an okay way to write this. If I could also write it as that x to the 9th and y to the 3rd in the numerator over 2. Either one of these I think is pretty good. But notice, no matter how I say it, the coefficient is 3/2. And then we very much just briefly touched on this in chapter 1 and 2. That is, if I'm multiplying two binomials together, 2 terms times 2 terms, I have 4 multiplications to do. This x has to distribute to both x and the negative 6, and the positive 5 has got to be distributed to the x and the negative 6. And remember that we said we can FOIL it, multiply the first terms, the outer terms, the inner terms, and the last terms. If you multiply the first terms, you get x squared. The two outside terms, x and negative 6, give you negative 6x. The two inside terms, positive 5 and x, give you plus 5x. And the last terms, positive 5 and negative 6, give you negative 30. Typically, the o and the I, the oi, are going to be like terms that I can combine, and that's the case here. And that would be my simplified trinomial answer. So take a second and do number 6. Come back when you have the answer. Okay, again, 3x squared minus 14x plus 16. You can see what I did there. And is that the end? I had one more slide. Nope, that's it. All right. Very good. Namaste. Sorry, this is a bit long, and we'll go on to solving quadratics here in a second.